So sample problem number 3. So we have to find the magnitude of the current density J in a sample of silver for which the conductivity is 6.17 times 10 to the 7 Siemens per meter. And the electron mobility is 0.0056 meters squared per volt second. So for letter A, so if Vd, or the drift velocity, is 1.5 micrometers per second, so let's calculate the current density. So let's calculate the current density J. So to solve for the current density J, so it's given by Ohm's law, which is sigma times E. So we already have sigma, but we don't have E. But we can compute E from these quantities. But we know that the drift velocity is equal to the electron mobility times E, which is the electric field. So to compute for E, so E is equal to the drift velocity divided by the electron mobility. So since we already have these two quantities, we can solve for E. Therefore, J is equal to sigma times E, which is drift velocity divided by the electron mobility. So by substituting the given quantities or given values, so sigma is equal to 6.17 times 10 to the 7 Siemens per meter, and Vd, or the drift velocity, is equal to 1.5 micrometers per second, all over the electron mobility. So the electron mobility, mu sub E, is given by 0.0056 meters squared per volt second. So that is 0.0056 meters squared per volt second. Okay. So this gives us 16.5 kilo amperes per meter squared. So this is the answer for letter A. So this is J for letter A. For letter B, we are still given the same conductivity and electron mobility, but this time E is given as 1 millivolts per meter. So we will use this to solve for J. So using this value for E, we can solve for J. So J is equal to sigma times E, but sigma is equivalent to 6.17 times 10 to the 7 Siemens per meter as given, and E is equal to 1 millivolts per meter. So this will give us an answer of 61.7 kilo amperes per meter squared. So this is the answer for letter B. So for letter C, we are given the dimensions of a cube. So the side of the cube is 2.5 millimeters and the voltage is 0.4 millivolts. So how can we solve for J? So we can solve for J by again using the formula, or Ohm's law, sigma times E. So we already have the constant sigma. So this is letter C. So how can we solve for E? But we know that the voltage is equal to E times D. Therefore, E is equal to voltage divided by D. So we will use this expression or equation to solve for J. So we will replace E by V times D, the distance. So if we have a cube, so the side of a cube, S, is equal to 2.5 millimeters, and the current will be flowing in this direction, and the voltage is applied across the cube, or the length of the cube. Therefore, we can solve for J. So J is equal to sigma V over D. So sigma is equal to 6.17 times 10 to the 7 Siemens per meter. So it is given times V. So the voltage, the given voltage is 0.4 millivolts. So that is 0.4 millivolts divided by D. Okay. So that's 0.4 millivolts. So let's divide the entire numerator by the denominator D. So D is equal to 2.5 millimeters. Therefore, we get the answer for J, which is 9.9 mega amperes per meters squared. So that's letter C. So for letter D, we are given again a cube with the side having a length of 2.5 millimeters, and the total current passing through the cube is 0.5 amperes. So how can we solve for the current density J? So we can solve for the current density J. So this is letter D, by using the definition of the current density, which is I over the area, because we know that the current density is the amount of charge or the amount of current flowing through an area. So we're already given with the current. So this is 0.5 amperes, and the area is the area of the cube. So how do we compute for the area of the cube? So the area of the cube is just the square of its sides. So the square of one side is 2.5 millimeters squared. Therefore, we will be getting an answer for the current density of 80 kiloamperes per meters squared. So this is letter D.